center of mass. So what is our summary that we just learned? The first thing that we learned is that there is a center of mass vector Cm or Cm, right? And how did we write? Do you remember? M1 R1 plus M2 R2 and so on plus Mn Rn. Do you remember? Divided by what? Tell me. And so on plus Mn, right? And then we can also write it sigma Mi Ri, and I belongs to 1 to n divided by sigma Mi. Agreed? So this was my first learning. The second learning was that RCM as it is, we could have written as M1 R1 plus M2 R2 upon M1 plus M2. This was for two particle system, right? Particle system. Remember? अभी हम इसे अप्लाई करके भी देखेंगे. And the third point was the corresponding x, y and z cm. xcm was m1 x1 plus m2 x2 and so on plus mn xn upon m1 plus m2 and so on plus mn. Okay. Now ycm would be same. Okay. YCM would be M1 Y1 M2 Y2 plus Mn Yn M1 plus M2 plus Mn. Okay. So this is how we can calculate. Similarly, ZCM M1 Z1 M2 Z2 plus Mn Zn upon M1 plus M2 and so on plus Mn. Okay. So that was our discussion. And then for continuous mass distribution, what was the formulas? You could written as RCM as 1 upon capital M RDM. Will you remember it? अभी हम लोग क्वेश्चन करके देखेंगे. Similarly, XCM is 1 upon capital M XDM. Similarly, YCM would be 1 upon capital M YDM, and then ZCM 1 upon capital M ZDM. All right. And then we can also say my VCM was M1 V1 plus M2 V2 upon M1 plus M2. Okay. Now let us do application questions. So let us say I take illustration 1. So first illustration, let us say there is a lamina, a triangular lamina. We are learning the application part now, how to apply this whole thing. LMN, आपको एक triangular lamina दिया हुआ है. Okay. It's just a sheet, triangular sheet. Yeah, lamination कहते हैं ना जैसे. It's a triangular sheet with vertex LMN. Okay. And Find the center of mass of a triangular lamina. That is the question. Find the center of mass of a triangular lamina. So, if you really want to know किसी भी triangle का जो center होगा वो क्या होगा? Can you guess? You can achieve the central point as centroid. Centroid means joining the midpoint. Let us say MN का midpoint क्या है? E. So join L with E. And LN का midpoint क्या हो सकता है? F, G, M, M. Yeah. Correct? And similarly, if I join F and then the third will be joining to, let's say, point G, which is actually the midpoint of L and M. So this cross point is O. O is known as centroid. Centroid of the given triangular lamina. ठीक है जी. So this O is the center of mass. Let us take another question, and I'm writing it. No, but before I declare that it is centroid, did you have an idea where exactly will this lie? So this is what I told you earlier, that most of these figures, if you find some sort of symmetrical approach, then you will find the center of mass. Okay. Now let us try one next level of question, and this time I will give you full opportunity to diagnose the problem. Okay. So let me write 3 masses 3, 4 and 5 kg. 3 masses 3, 4 and 5 kg are located at the corners of an equilateral triangle. At the corners of an equilateral triangle. Equilateral triangle of side 1 meter locate the center of mass of the system. What? No, अभी कुछ मत करो. Shut down. I told you yesterday, keep your phones aside and do not even look at your phones. I told you during the class, let us simply me and you. There is no third party. Okay, keep your phone aside. You can of course see your phones when you are at home. You have full liberty, no? Right? Let me write down and draw this triangle like this, and this is your origin. Now you can write down this O and O, B let's say this is point A, and your masses are M1, M2 and M3. Okay, now M1 corresponds to 3 kg, M2 corresponds to 4 kg and M3 corresponds to 5 kg. Okay, now you can go ahead and solve this problem. Apply the learned theory. At the best, you can take 1 or 2 minutes, not more than that. You will get in examination 2 mark. So you can just take 2 minutes. So what is the first thing that we should do? Tell me. After you learned all the theory. You wanted, all you want is that it's a 2D figure, right? So you want an axiom and you want YCM. So can you tell me what was the formula for axiom? M1x1 plus M2x2 M3x3 upon. Similarly, let's put our learned theory for in practice for the next one. M1y1 M2y2 M3y3 upon M1 plus M2 plus M3. Yes or no? You know all these M1, M2, M3, right? That I have written already on the top. What is x1, x2, x3? Can you tell me from the figure? X1 is 0. So let us try to put M1 was 3 times 0 plus x2 क्या है? x2 is the coordinate of M2. M2 का coordinate क्या होगा? x2, y2. क्यों नहीं बोल रहे हो? So x2 कितना है? 1. So 4 times 1 plus 5 times x3. x3 कैसे निकालेंगे? यहाँ से एक vertical line डाल दीजिए. Let us say BM. Okay. So my x3 would be which one? OM. x3 will be this. So OM कैसे निकलेगा? OM will be half simply. M is the midpoint. Okay. So क्या लिखोगे आप? 0.5 upon 3 plus 4 plus 5. Tell me, what is your answer? Three into 0 is 0. 4 into 1 is 1. 5 times 0.5 is 2.5. 4 plus 2.5 will be 6.5 divided by 12. So what is our answer? 0.54, okay, meter. Similarly, can you calculate YCM on your own now that you know everything? So again, let us try to write down M1 Y1. So what is my M1? M1 remains 3, yes or no? Times Y1, 0. M2, 4. Why would Y2 would be 0? Y2 is on the x-axis. Okay. So Y2 is also 0. Plus 5 times Y3. And what is the value of Y3? So OB is a hypotenuse. Can you not calculate? 1 square minus 1 upon 2 square would be BM whole square. BM is your Y2, yes or no? Y3 rather. So what is Y3? Y3 is under root. That would be 3 by 4, yes or no? So you can say it is root 3 by 2, yes. So can we write down here and find what is our final value? 5 times root 3 upon 2 and whole thing upon M1 plus M2 plus M3 was 12. Okay. Tell me. So we are getting 5 root 3 upon 12 into 2 becomes 24. So you can calculate it 5 times 1.73 upon 24. Okay. Can you tell me what will be your answer? I'll simply put the value. Your answer would be 0.36 meter. You can just multiply it and divide by 24. So the coordinate of center of mass is, therefore, the coordinate of center of mass is 0.54, 0.36 meter. Tell me. Your timelines are pretty small in the examination. That's why we need practice. More and more practice, physics becomes smoother. Okay. Let's do one more question. Give it a try on your own. Two particles of mass 100 gram. Two particles of mass 100 gram, okay, and 300 gram are have position vectors vectors 2i, 5j, 13k and 6i, 4j, minus 2k meter respectively. And their velocities are 10i, minus 7j, minus 3k, okay, and 7i, minus 9j, plus 6k meter per second, okay. Determine the instantaneous position and velocity of CM. Determine the instantaneous position and velocity of center of mass and velocity of center of mass. Give it a try. Apply the formulas. Always, if you really want to crack your question, you must write down the data. So write down your M1 and M2. What is your M1? कितना है? So 100 ग्राम को किस में कन्वर्ट करोगे? kg में, 0.1 kilogram. Similarly 300 gram is what is the second? So 0.3 kg. This is how you have to write your data. Similarly, write down your corresponding vector R1. R1 is 2i, 5j and plus 13k, and R2 is minus 6i, 4j, minus 2k हैं? एक मिनट हैं? या हाँ, ये मैंने शायद भूल गया, यहाँ पे मैं नेगेटिव लिख लेते हैं, ओके। ये डेटा है तुम्हारा, तो इससे अगला स्टेप क्या लिखोगे जरा बताओ। आ रहा, आप ट्राई करो, बताओ। हाँ, पहले तो आपको इंस्टेंटेनियस पोजीशन पूछिए ना, वेलोसिटी तो सेकेंडरी बात की है। सो व्हाट विल बी योर इंस्टेंटेनियस पोजीशन? बोलो क्या लगाओगे? जो अभी मैंने थियोरी सिखाई है उसमें से क्या चीज पकड़ोगे? हाउ विल यू नो? So if you want instantaneous position, you write your RCM. It will be M1 R1 M2 R2 upon M1 plus M2. So write down all the values and find out and let me know what is your RCM. M1 is 0.1, R1 is 2i, 5j plus 13k plus M2 is 0.3, negative 6i 4j minus 2k, all right, upon m1 plus m2, and m1 plus m2 will be 0.1 plus 0.3. Now please solve it and let me know what is your final answer. x के कंटेंट जोड़े तो कितना आया, नेगेटिव 69 आ रहा है क्या? और नीचे जो 0.4 है ऊपर नीचे 10 से मल्टीप्लाई कर दो तो नीचे 4 आ जाएगा. टेल मी, इज दिस व्हाट योर आंसर कम्स? इफ इट इज नॉट देन लेट मी नो वेयर इज द इश्यू. Are you getting this or not? निकालो. सेम आ रहा है ना? वेरी गुड. अब हमें VCM निकालना है बिकॉज वेलोसिटी के बारे में बात की है हमने. सो VCM के लिए क्या करोगे? V1 एंड V2 लिखोगे. राइट डाउन योर V1 एंड V2 वेक्टर. V1 वेक्टर इज 10i 7j 3k मीटर पर सेकेंड and V2 vector is 7i minus 9j plus 6k मीटर पर सेकेंड. समझ रहे? सो माई VCM क्या था फॉर्मूला, याद है? सिंपल है, ज़्यादा मुश्किल नहीं है. m1 v1 प्लस m2 v2 अपॉन m1 plus m2. Can you quickly write down your values and tell me what is the final answer? So we would write 0.1 multiplied by V1 की quantity 10i minus 7j minus 3k, then multiply plus 0.3 times 7i minus 9j plus 6k, and then m1 plus m2 was 0.4. 31 I cap minus 34 J cap plus 15 K cap upon 4. What about others? हैं? कर रहे हो ना? हाँ करो करो, शाबाश. There is no problem. You can find out if there is some problem with this data. If you are investigating, try to make sure that you are learning the subject. So today I will be giving you a worksheet of center of mass. When you go home, try to do that. Okay? आ गया? हाँ जी. आप 31 नहीं आएगा. जब 0.3 से मल्टीप्लाई किया -9 को तो 9 3 जा 27 आता है. हाँ, and then उधर 0.1 को 7 से मल्टीप्लाई करो 0.7, so 2.7 plus 0.7 will become 3.4, और जब 10 से मल्टीप्लाई करोगे तो 34 आ जाएगा. ओके, so this is our VCM and measurement will be in meter per second. So tell me, have you learnt the fundamentals and how to really sort out the problems and application of center of mass? So let me just close it here. I'm sure this would help you.